Hello everyone. Uh, Today we are going to discuss about circular linked list, and we'll see the implementation, how we are going to implement this circular linked list. Okay. So what is this circular linked list? We have seen the definition of linked list. So linked list is nothing but which consists of nodes. Each node consists of two parts, information field and address field. Information field stores the information or data, whereas link part or address field stores the address of next node. Okay, so that is what we have seen. We have seen various linked lists such as single linked list and double linked list. So there are some drawbacks of a single linked list. We went to double linked list. In single linked list, only we can move only in one direction. We can't move in backward direction. Only we can move in forward direction. Suppose if you want to come back, it is difficult in single direction. So to overcome that, we went to double linked list, where we are having a node which consists of two link parts and one information part. So in these two link parts, so first link holds the address of previous node, and next link holds the address of the next node. Okay. So in the data field, we are going to store the actual data, whatever we need to store. In this way, we can move in forward direction as well as in backward direction. So that is about double linked list. In both the cases, if you observe in single linked list and double linked list, so the last node, the address field of the last node is null. That means there is no other node in the list. Okay, but suppose instead of placing null, if it again points to the first node, if you are holding the address of the first node, then we will say that linked list as circular linked list. Observe here, in single linked list, every node points to its next node in the sequence. We are just pointing to the next node, and the last node points to the null node. Okay, as nothing is there in the next node, so no node is there. We are just pointing it as null. But in circular linked list, every node points to its next node. So here also we are pointing it to the next node in the sequence, but the last node points to the first node in the list. Okay, in the address part of the last node, we are storing the address of the first node. That means it forms a loop. We can say it as circular linked list. Okay, a circular linked list is a sequence of elements in which every element has a link to its next element. Every element has a link to its next element in the sequence, and the last element has a link to the first element. Okay, so this is the definition of circular linked list. Observe here, observe this diagram. If you observe, this is my first node 21, 22, 23. So actually in single linked list, here you will find none. Okay, null. Okay, that is the end of the list. But here in circular linked list, here again we are storing the address of first node. What is the address of first node? It is 2000. So we are just placing here as 2000. Okay, so this is about circular linked list. I hope it is clear. So we'll see various types of operations performed on circular linked list. Okay, fine. See here. So whatever the operations we performed on single linked list and double linked list, so we will be doing the same thing. We'll be performing those same operations here in circular linked list also. Okay. So here we're performing some operations such as insertion, deletion, and display. Display nothing but traversing. So in insertion, again we are having three types: insertion at beginning of the list, insertion at end of the list, insertion at specific location in the list. Okay, similarly, deletion also, deletion from beginning of the list, deletion from end of the list, deleting it at some specific position in the list. Okay, then traversing. Okay, we'll see one by one, starting with insertion. So coming to the first one, insertion at beginning of the list. Okay, if there are no nodes in the list, if the list is empty, okay, observe here, there is no node in the list. Okay, now I am trying to add a new node. Okay, so if I add a new node, what happens? I need to place the address of 5000 here in place of none. I need to place address of 5000 here. Then here, if it is single linked list, here I will be placing none only. But as it is circular linked list, what I need to do? I need to give the address of first node. As this node itself is the first node, here I need to place the address of this node as 5000. Okay. So here, so we'll be getting like this. So 5000 is placed here, and here I am placing 5000. So which forms which looks like a loop. Okay, a node pointing to itself. Okay, so this is about insertion and beginning of list if there are no nodes in the list. Okay, let's see if there are nodes in the list. Observe here, here there are two nodes, 21 and 22. So as this is a circular node, so where here I am storing the address of first node. First node address is 5000. I am just giving it as 5000 here. Okay, this is the circular linked list we have. Now I am trying to insert a node at beginning of the list means, so here I need to insert. Okay, so here I need to insert. We'll see how we are going to insert. If we insert here, what happens? So here. 5000 is stored here. Why? Because earlier this is the first node. So after inserting, so 8000 should come here. So this one becomes the first node. 8000 should come here, and 8000 should be stored here also. Okay, observe here. See, observe here. So I'm just placing 8000. So this is my new node, and then see. So I'll remove this 5000 and I'll just place 8000 here. Here I'll placing the address of this node 5000 I placed here. Okay, I just removed none. I placed the address of 5000. So finally 8000. So this is my starting, and here I'm giving 20 and 5000. So this is this node becomes my first node. So like this. So here I'm going to give the address of the first node, that is 8000 is given here. Okay, I hope it is clear. You just go through again the same diagrams. Very simple thing. So this is the thing. I just in place of 5000, I just give the address of this first node. Okay, that means 8000 should come here. So 8000 should be placed here, and in place of none, I should place the 5000. Okay, so simply I'll be getting the last as like this. Okay, so then insertion at end of the list. So I need to insert the node at the end of the list. If nothing is there in the list, so I'm just inserting my node at the end. Okay, I'll be just giving the link here, and I'll be giving the in place of none, I'll be giving the address of the last node. Okay, address of the first node. So as this is the first node, I'll be giving the 5000 here. Okay, I'll be getting similarly similar to this. Okay, I'll be getting like this. So I'll be just storing my 5000 address here. Here also I'm be storing 5000, as this is the circular list. Okay. Suppose if there are elements in the list. Okay. Now observe here 21. This element is there. 21 and 22 are the nodes present in the list. I am trying to insert 20. So where I need to insert? I need to insert at end of the list. Okay, so I'll be placing this at the end of the list. I need to move from first node to second node to last node. Okay, I'll be moving like that. There I'm going to insert, and in place of none, I'll be storing the address of 5000. Okay, as this is the first node, I need to give the address as 5000 here. Okay, here in place of 5000, I should give the address of 8000. Okay, so here I am going to insert. So we'll be getting clear idea. If you observe, for moving to the last, first I will consider this one as temp. Then I will move my temp to next node. Okay, so then so as it reached to the as I have seen the next point, next node, I mean address as first node address. So I think this is the last node. Okay. So now what I need to do is here I'll be adding the address of my new node. Okay. See here. So this is my new node. I'm just adding this 8000 here. Okay. So in place of none, what I need to do, I need to give the address of the first node, that is 5000. Okay, so observe here. Here I'll be getting 5000. Okay, so in this way we are going to insert a node at the end of the list. Now insertion at specific location of the list. Okay, we need to insert the element at given position. So as there are no elements in the list, so I am simply inserting the element as we have seen in the insertion at front and insertion at end. So both are similar. Okay. Here also same thing. In place of none, I will be placing 5000. Okay. Just I'll be getting like this. None. So in place of none, I'll be getting 5000. So I'll be pointing like this. Okay. Suppose if there are elements in the list like this, insertion at specific location of the list. So in this, suppose if there are elements in the list, then where I need to insert, I'm trying to insert that position 2. Okay, I need to check. First, I will think this one as temp. I'll consider this one as temp, and I will check whether the position I have reached. Okay, if I have not reached position, so I'll just move my temp to next. Okay, this is position 1. I'll just move to the next one, next location. See here. So temp and I equal to 1. So this is not equal to position. Next, I'll be moving to my temp here. Okay. So then, as I reach it to the last, so I mean, as I reach it to the position, what I need to do, I need to insert the element at the second position. Here I need to insert. In between 21 and 22, I need to insert. Okay. So that means, so for that new node, I should give the address of 6000. Observe here. For the new node, so here I will be just removing 6000 and I will be placing that 8000 here. Okay, here what I need to do, I need to remove this none and I need to place 6000. Okay, so we are not disturbing this link. So I just I'm trying to insert at the given position. Okay, here I will be storing the address of this node and here I will be storing the address of this node. That means here I will be getting 6000. Okay, so this is the final thing. Okay, final diagram looks like this. So that is about insertion at beginning, insertion at end, and insertion at given position. Now let's see deletion at beginning of the list. Okay, uh, observe here. So there is only one node. There is only one node in the list. So now I need to delete this. If I delete this, what happens? So here I need to remove that 5000 and I will be just placing my none. Okay, so as nothing is there, if I delete this, list becomes empty. Okay, now here I'll be getting none. Okay, see here, it becomes like this. Okay. So this is where when there is only one node in the list. Suppose if there are many nodes, if there are many nodes like this 21, 22, 23, observe here. So now I am trying to delete at beginning of the list. If I am trying to delete at the beginning of the list, so that means I'll be deleting this. If I delete this, what happens? This node becomes first node. Okay, that means so in place of 5,000, I should get 6,000. Okay, and here also in place of 5,000, I should get 6,000. So this link should be removed and it should be given to here. So I'll be getting like this. So I'll be moving to the last and observe here. Here I'll be giving the address. First, this one will be given here. Next, then this one will be given here. I simply remove this. So you'll get only 22 and 23. So I'll just remove that 21. Okay. So here I'll be storing the address of this first node. Here I will be storing the address of this first node. Okay. I hope it is clear. Okay. You just go through the diagrams clearly. You'll be getting a clear idea. So simply I am deleting the links. So I need to remove this link and I need to give the address of this one to here and the address of this one to the last node. Okay. So this is about deletion at beginning of the list. Now deletion at end of the list. Okay. Suppose if you are trying to delete at the end of the list, so this is simple. Both same as deletion at the beginning also. If this there is only one node, I'll just simply delete this. So in place of 5,000, I'll be getting none. Okay. So I'll be getting only none. I just removed this. So suppose if there are elements in the list, suppose if there are elements in the list. So observe here. So we are having 21, 22, 23 elements there in the list. So now I am trying to delete at end of the list. That means I need to delete this. If I need to delete this, so what happens? Actually, if this node is deleted, the address is stored here. This node address is stored here, 7,000. So in place of 7,000, I should give the first node address. That is 5,000 should be placed here. Okay. So first I'll start from this position to the last position. First I will think this one as temp and I'll move my temp to here and I will move my temp to here until I reach to the address of first node. Okay. See, observe here. I reached here. Ultimately, my temp comes here. I'll be just deleting this. I'll be just deleting this. Here I am placing the address of this first node, that is 5,000. So here I'll be placing first node 5,000. Okay. So simply I'm going to delete that. This is the deletion at end of the list. Deletion at specific location of the list. Observe here, if there are only one element, one node in the list, I just simply delete this. So here I'll be getting none. Okay, I'm just getting only none. So I just deleted only one node. Suppose if you are trying to delete the node at position 2, so I need to go to that position 2. So I will start from my first node and I will move up to the position. Okay. So I'll be considering first node as my temp and I will check my position. So if I have reached the position 2, no, I have not reached. So now I'll move my temp here. Okay. So I'll come to here. Okay. So then after reaching the position, as I reach to position 2, now what I need to do? I need to delete this. I need to delete this. If I need to delete this, so what happens? Here I have stored the address of this node here. So in place of 6,000, I should get 7,000 here. Okay. I'll be just deleting this. In place of 6,000, I should get 7,000. Just I got 7,000. Okay. I'll be removing this. Okay. This is about deletion at specific location in the list. Okay. Then traversing. So traversing is nothing but we are moving from first node to last node. Okay, as we have seen. So we'll start with the first node. So then we'll move to the next node. We'll shift the temp. Okay, we'll shift first temp points to the first node. Then we'll move to the next node. Then we'll move to the last node. Okay, until we reach to the last node, we'll be displaying all the values in the nodes. Okay, so this is about traversing in the observe here. So first I reached 21, then I reached 22, then I reached 23. Okay, I hope it is clear. You just go through all the slides, all the animations, you'll be getting a clear idea. Okay, thank you.